really interesting at the core of anything that sounds boring, and that's why I like being an actor. But I am also way overdressed for this office compared to ours.
That's fine. When I go to game, I had this one time where I went to a meeting at like a corporate meeting in New York and also a game studio afterwards, and you have to construct an outfit whereby you can transform from like I'm in like this Fifth Avenue office to like I'm in some like
Totally
place in like Chinatown. It's great.
Oh wow! If that's your diary, then I appreciate you.
Welcome to the Thunderdome. It's pretty cool. So, in terms of should we start with the first section of in case I got pulled out and everything sets on fire, going into like spatial as a technology, and I guess we can talk about.
Perfect. Let's do that.
There's two ways I can go about it. One is kind of doing it from the perspective of like what it concretely. Kind of the end user will see as an effect of people using spatial OS. The other one is kind of a bit more of a kind of popping the hood kind of explanation.
Let's do popping the hood, because cool. I think I have the use cases / what you're offering to developers, but the thing that I want to understand is how is the current state of simulation and this kind of technology, and how you guys differ and build on what.
As an aside, I think we actually have Spilt Milk in today, so they could show you how a game, how the back end of the game running on Spatial OS.
Great.
I've also got. Has anyone ever run you through actually our deployment tools or actually shown you anything?
No. I've seen World Drift up and running and the kind of things that you do with the inspector, but I've not played with the tools very much at all.
Okay. So we can probably sort of have a look through that. There's my favorite little kind of I can even run you through the onboarding experience whereby it's the initial project you download from GitHub and launch.
Okay.
And so you get a diorama. It's kind of it shows all the core pieces of the technology working together in unison in a smaller form. And that's actually what you have access to when you get access to the SDK. And you can see two workers cooperating. You can see lots of things running at each other. Like I'll warm one of those up now. It takes a while to kind of the wizards to start really beating the crap out of each other. So.
That's wizards as in actual wizards, right?
So the wizards are a core technical concept. It's they are in fact
literal wizards.
Literal wizards, yes.
Within the demo.
Okay. I kind of got lost down the rabbit hole of your blog and all of the what they call murmurations of starlings. You've got the bird block.
Oh that's pretty cool.
And the dominoes and the cities, and it's quite helpful. I think it helps that everything plugs nicely into game engines so that you get pretty visualizations.
People love that. So let's start from kind of how much are you aware right now of kind of the state of the art before spatial OS in terms of how online games tend to run and what they tend to look like?
So I've not.
I guess you play many games yourself as well.
I have played many games for many years. As to how each of them runs what they do, I'm much less familiar with it.
Yeah, cool. So let's start from there, and there's kind of a really nice kind of taking that narrative through to suppose if you did this, this, then we can kind of go through, and then you can kind of transform the traditional architecture into spatial OS. And kind of hopefully, if you're kind of trying to, if anyone's reading that and someone's familiar with existing structures, you could almost explain the diffs.
Yeah.
To get that. So with most games which kind of have anything quite going on, there is usually a dedicated server.
Yeah.
New pens, yes. True. And this is a thing which is often running on, a single VM or dedicated machine, either in the cloud or in some kind of data center it's been released from. And this dedicated server is responsible for the entire world within a kind of game environment. So it's responsible for every single person connecting into this dedicated server.
Yeah.
Is responsible for synchronizing the view of the world. It is kind of the god of the world, kind of synchronizing the state of that to everybody here. It's responsible for your physics, for the AI, for the pathfinding if there's any monsters inside this environment. And as a result, you kind of get into some trade-offs which aren't very nice. Either the world is kind of very high in fidelity, and you have very few people. So you look at kind of the best in class thing that would be your likes of games like kind of Battlefield.
That's the one. Is what I was going to say.
Yeah, and that's kind of you're pushing towards 64 players max. You've got kind of a lot of interesting things going on, but it's still constrained. It's finite as well. It only lasts for a certain amount of time. So you've got a maybe like sort of 30 minutes is kind of a classic kind of like sort of duration of time. And there's these fantastic environments where you've got physics, you've got things falling down, you've got players running around. But in terms of it being like sort of larger and maybe more meaningful, it doesn't really have that. On the other side, you get kind of MMO games which are larger in physical scale, but the world itself has a lower fidelity, which is a tool which enables them to have lots kind of more people interacting in one region of the space, maybe kind of like sort of hyper maybe, and they tile the world by having loading screens. So when you move from this side of the world to this side of the world, when you go from the forest to the desert, there's a loading screen. And then if like you had some camel chasing you in the desert, and then you go through into the forest, the camel just disappears. So it's the illusion of a world being this kind of seamless environment, and it means it kind of, again, it's not quite meaningful then. Actually, if I do something over here and run away and come back again, it's just as if nothing had really happened. It's kind of like a theme park. There's a series of rides you can go on, you can walk over and do different things. So the kind of original idea we had back in the day for we wanted to take this, we wanted to be able to enable truly living game worlds where the world itself is filled with an ecology. Literally, the trees were going to grow. There was going to be like sort of a full ecology of animals and plants. There was going to be a full economy going on, and a lot of things going around, and the players themselves are actually completely incidental inside of the world. So with Battlefield 1, if no one logged in, absolutely literally nothing happening. And World of Warcraft, if no one logs in, still there's like nothing happening. It's just kind of like it's empty. It's like it's a theme park where all the rides have stopped. Oblivion in old towers is waiting there. The dragon's waiting there for someone to go kill it. And even like sort of games which are living worlds right now, something like EVE Online. The game would start. The game's dynamism and interest is driven fundamentally from players and interaction. So we knew that for us to make a world that's truly living and alive and simulated, we need to have a way of having multiple machines rather than a single machine cooperate and combine their power together to be able to simulate a world much larger than any single one could ever deal with. Adding to the fact we also wanted it to be as high fidelity as a game like Battlefield or Call of Duty, and scales far larger than this, we knew we were going to have to kind of do something new. And I guess where did we go from here? Where was the first place to take it? So there's a few this is going to get a little bit more dry, but I don't know whether
dry is what I want.
You can
dry is what I'm after.
Nice.
So dry is where the meat, the real stuff is.
Yeah. So in terms of what breaks when you start to add lots of people inside this world and make this world complex. In terms of this machine, it's gonna run out of CPU. It's gonna like sort of run out of literal computational ability to simulate all the physics and do all the cool stuff, and it's gonna run out of kind of networking. It's gonna run out about its ability to update the world. Update these people. That's just kind of where it's gonna fall down, and that's kind of where you find pushing from 32 to 64 players gets harder and harder because the problem doesn't grow like linearly. It grows quadratically, which is because if I have n people in an environment and we're all looking at each other, all doing buddy cops, then we have to synchronize. N of us are sending those inputs, and also there are n of us who need to see the n inputs. So it's actually like around n squared kind of interaction going on. So it gets to a point where you get almost a cliff on how far you can push this. So imagine a new architecture. This is super dry.
No.
With the where
I spent my weekend reading about Monte Carlo simulations. Like this is my jam right now.
So in terms of imagine Spatial OS is a distributed operating system. So this VM is ultimately running probably like a base operating system like Core OS. Imagine a layer.
Hey, how's it going? Let's see.
Imagine
You have a new haircut? Looks smart.
It's a long and complicated
I'm convinced he's in the short back and side crew now. Living the dream. So imagine a distributed operating system where it's an abstraction on top of a cluster of machines. So under the hood there's actually lots of VMs, and this is an abstraction of like lots of computer programs actually running on each of these individually, and then wiring together to form an abstraction which kind of presents a view of a single big computer. The cool thing about this is if you can intelligently allocate CPU is now working across these machines, you can